Okay, the next topic is to figure out domain and range of a function. Now, so far we dealt with a lot of domain problem, but not so much of range problem. Well, mainly because it's a little bit more complicated, right? So, domain and range. Domain and range, and we're going to try to figure it out using inverse um, inverse function. So let me give you an example. Let's say we need to figure out um, domain and range of this function. Say 2x plus 1 over x minus 1, and find the domain and range. Now, domain is relatively easy because what's domain? Possible x value. What x value that we can use and what x value that we don't want to use. Well, basically we can use any x value, but we don't want x to be equal to 1 because it'll blow up here. So basically domain would be all real number but x cannot be equal to 1, right? That's domain. I mean, in some case that they use this set notation, say it's going to be set of x in this bar and x cannot be equal to 1 and close it. And it's basically this and this are the same thing, right? So you can write it like that or you can write it like that. Range, however, range is possible y value, but it's kind of difficult to figure out what would be the range of this. So range of f of x is equal to domain of f inverse x, right? Range of this function f of x is same thing as range of this inverse function. So because it's difficult to see the domain of this, I mean range of this, if we find the domain of inverse, then we can find the range of this function. So what's the range? What's the uh, inverse function of this? Remember that. Oops. F of x was 2x plus 1 over x minus 1. We need to find the inverse of this function. Now we tried this question in our previous video, but let's do it again. If you I want you to pause this video and try to find the inverse. See if you can find now. So step 1, fx2 y. So y equal 2x plus 1 over x minus 1. Now step 2, x and y switched. So it'll be x equal to y plus 1, x minus 1. Now step 3, solve for y. You know what? That should be y2. Right, sorry about this because we are changing this y, this y. So in looking at this over 1, we do cross multiply this times this. So x times y minus 1 is 2y plus 1. Multiply these two. So we are simplifying this. Xy minus x equal to y plus 1. Moving this to here, x to there. Then it'll be xy minus 2y equal x plus 1. Vector with y, it'll be x minus 2, x plus 1. Divide both sides by x minus 2. Cancel. Y equal x plus 1 over x minus 2. Now step 4. Let y become inverse of x. So inverse function of this would be x plus 1, x minus 2. Now, remember what we need to find is range of the original function. We know the range of the original function is same as domain of the inverse function. So we just found the inverse function. What's the domain of this? Domain of this would be all real, but x cannot be equal to 2, right? Because of this denominator part, right? We don't want that too. Now, this is a domain of this inverse function. Now, that domain of this inverse function would be same as range of f of x, which is the original function, is going to be same as this. So all real number, but x cannot be equal to 2. That's the range of the original function, right? So let's just recap. We wanted to find domain and range of this function. Finding domain was relatively easy because we just need to check the denominator, and we do not include that denominator in our domain. In order to figure out the range of this function, we find the domain of inverse function because they are the same thing. So this was the original function. We tried to find the inverse function first, and inverse function that we did. So domain of this inverse function, which is this, is same thing as the range of the original function, which is this. Okay. All right.